let's talk about the equinoxes. And this is a very critical thing we need to understand. Since the sun is rotating around the earth in a year, and since earth is offset, the position of the sun relative to the earth isn't going to be when the sun reaches its nodal point. It's going to be before, because as we can see, that's when the sun is perpendicular to earth. Therefore, as the sun reaches the perpendicular point, that's the equinox. It's always been the equinox down through the epochs. They tell you today this point is the equinox. So when you look for the equinoxes on the web, you're going to get an erroneous date. What you have to look for now, because since their model is so broken, they've had to create a new term. That term is called Equilux, which means equal day. This is the kind of nonsense you have to wade through with a childish model. So when you look for the Equilux dates, you will see that they will typically be about 3 days and some change before the actual equinox, which by the same token, in the autumn, the sun is going to be a little bit late to that perpendicular point. So what we've got is a difference between the equinoctial points. This is spring equinox. This will be fall equinox. That means the sun has a larger arc to travel from spring to fall versus fall to spring, because it's closer. This is the reason why there's a discrepancy between the two halves of the year. They're almost 8 days difference. So if you look up the Equilux now, you'll see that those two halves are different. And that's because you've got, if you had equal, Earth was in the middle, then you've got this arc right here, semicircle is 180 degrees, so you got a full 90 and 90. But in our case, that doesn't happen because this angle is less, so you have less than 90 degrees up here and you have more down here. It may seem a little counterintuitive at first, but the smaller the angle, the slower the appearance of the speed. Larger angle, the faster the appearance of the speed. So since the two halves of the year are not the same, and you can really make out the difference. This is exaggerated, but so this is what clued the ancient astronomers in that the Earth was eccentric to the sun. This is the way that the ancients determined the length of the year and the eccentricity. They knew that the 2 points from here to here and here to here were different. That was a dead giveaway that the sun wasn't centered on. That eccentricity causes the anomaly, or if you look up the equinoxes today, you'll find we're told that they occur right around March the 21st, something like that, and September. What they've done is they've taken the Earth, and because they say the orbit is eccentric, in their nomenclature, eccentric means at around. So they've taken 1 AU and offset that by 5 million kilometers. If you flip it and put the sun orbiting an eccentric Earth that's offset 5 million miles, what ends up happening is the sun will end up at that point right there. So it's going to end up right on the node, and by the same token, it's going to end up on the node over there. So that explains the equilux.